Now, our next presentation will be held by Dr. Markus Hennig, and he will talk about the challenges building an infrastructure for digital securities. Enjoy.
So, hello everybody, I hope you can hear me. So let's get started. I will speak about the challenges to build the infrastructure for digital securities or security tokens. So let's get started from the legal perspective. So in Germany, we just have, the Bundestag just passed the Electronic Securities Act, EWPG, which somehow allows the digitization of bearer bonds, fund shares, and hopefully later shares. So in a nutshell, at the moment we have paper certificates if you have security, which have to be in a kind of physical world. So it's a kind of really traditional way. And now the law allows somehow that instead of having a paper certificate, we can have a kind of electronic entry in a register or in a kind of a database, which then allows that we can issue securities using security registers without creating any kind of paper certificates. So that doesn't sound really kind of exciting, but at least on this side, it allows some kind of technical innovation here. So, but let's go a little bit into the law, but then later we'll go into more technical kind of points here. So the goal of the law is paperless electronic issuance. It will focus on bearer bonds, fund shares, and there's also like a legislative initiative planned for shares later. So the asset space will a little bit expanded. The law introduced electronic securities, which will be also like securities under the Custody Act, and they will be treated according to property laws. I mean, also without a certificate, and hence you have kind of bona fide acquisition possible. The law also introduced a kind of new entity. So this is kind of a securities register. So each security, instead of being a paper certificate, have to be registered in this kind of register. It's a kind of, you just imagine like a kind of database where you have all this kind of data you normally have in a paper form. If you want to custody these kind of securities, you have to have a license under the Custody Act. And so in this kind of new law, you have two kind of registers. So one is like central registers, which are operated by CSDs. So I would say this is nothing really new. It's more or less replaces this kind of paper requirement. But what is really new is like you have crypto security registers, which can operate or which can use distribute ledger technologies. Then you definitely have a kind of new financial service because you have this kind of registrars which are running this register. So this is a kind of new service which will be part of the market infrastructure. So there will definitely some kind of competition about it. And so the whole law is really kind of agnostic towards the technology. So you can use blockchain. It has some kind of, say, non-functional requirements within, which somehow implies, okay, distributed ledger technology is the way to go, but not necessarily. So what is the implication of the law? So from a kind of innovative perspective is that we have now introduced crypto securities, which now can leverage some smart contracts, say on a distributed ledger technology, and you can write or you can code processes and maybe realize cost savings. And you can also like maybe implement new features which we haven't seen yet in these assets, and you can also develop new services. So, but this also has an impact on the whole market because it somehow questions, say, the position of the CSD, because you have this new role of a security register or a crypto security register. So definitely there will be more competition on the market, and it will probably lower the costs over the life cycle of a security. And from the regulatory perspective, it will maybe lay also the ground for new tokenization laws in Germany. So it maybe is a kind of blueprint. It's not fully, say, perfect yet, but it will serve maybe for further laws. But as I said already, it's not perfect. There are some open questions. So there's a question about the registry if you need a CSD license, because say if you're a crypto registrar, you may also run the distributed ledger technology. You don't need to, but if you run it, you have a settlement system and you probably need a CSD license. So there's this kind of regulatory uncertainty here. Another thing is a kind of asymmetry between, say, electronic securities, so between the new crypto securities and, say, more this kind of tradition now called the central register securities, because the old ones you can still say trade on MTFs. But with crypto securities, it's probably not possible. But it may change on a European level, because there's this pilot regime coming, and it will probably this requirement will probably be abolished. So there's some kind of light on the horizon. And then there's kind of liability issue for the new kind of register service, because there's a kind of liability for, say, loss of data, unauthorized data modifications, or correctness of information. So it's not really clear what the scope here is, and it's something which must be clarified. But now let's start into getting into the technical details. So as I already mentioned earlier, so you have electronic securities, which can be in a central register. They call it the central register securities, living with a CSD. So this is nothing new. I would more say interpret it as a kind of technical improvement, because you essentially replace, say, a physical vault for securities, because they're not paper-based anymore. You can do it in a database fashion. So, but there's nothing pretty new to me here. So the real interesting part is the crypto security register you can use for, say, registering your crypto security. So there's some kind of, say, a technical innovation possible here. So now let's dive what we have to build actually, or to build, like I say, a new kind of infrastructure for crypto securities. So it's just like a vision, because it's not implemented yet. There's a lot of ideas flowing around. So the first thing is in this kind of say it's a DLT network, is the role of the crypto security register, which actually registers crypto securities when they are issued, but it also have to ensure kind of legal compliant transactions and ownership transfers. So it's a kind of, I would say, legal or compliance wrapper around your security, which somehow restricts your transferability, as I mentioned earlier, also in a talk by Robert. And the register also has to be responsible for always reflecting, say, the legal situation. So it's really responsible for everything around legal compliance, I would say, around the securities we have here. You definitely will have a custodian bank. As I mentioned earlier, you have the Custody Act, because they're securities, and somebody has to, do the custody services for it, and maybe also provide asset servicing. So you still have the custodian banks, and you probably, it's not sure yet, you will have crypto custodian more in a technical sense, because it could be, depends on the technical implementation, for, say, safekeeping private keys, if they're still involved. Really depends how you realize this kind of transfer of ownership. And what is really nice now is because you can use things like cash on ledger. So if you have like a corporate action, say like a payment, like a dividend payment, for instance, you can use cash on ledger maybe in the future. It's nothing what you can do right now, but in the future, this innovation is possible. And you will have something like, say, also like a token, say, asset tokenizer or security tokenizer, say, more like an issuance platform, which is, say, somehow responsible for the code, for the standards, but they have to work with a registry together to have it, say, to do it in a kind of compliant way. And also the registry needs to have access to the new asset here. So if you think about the infrastructure, there's certain things you have to solve. First you have to select the distributed ledger technology. It's essentially, okay, you want to go for, say, private permissioned, or you want to go for a public permissionless network. This is something where you have to think about, because there's a lot of kind of requirements in the law, and more a lot of kind of non-functional requirements which are not really clear. And so this is the first maybe step you have to do before you build any infrastructure. And so if you think about, say, the next challenges you have is about, say, everything about the securities. you want to have this kind of transfer of ownership. Hence, you have to build this new kind of securities register. So you have to think about how to do that in a kind of compliant way. And the other thing is, because, I mean, you'd say you have like bonds, you will have payments, and it would be nice if you could also like automatize payments here, because then you can really kind of digitalize, say, the securities. So let's go for the first questions, like, deciding if you go for private or public, because I mean there's a kind of non-functional requirements in the law. One is about finality, because it requires that, say, a security transfer happens in a reasonable time. So it's something which is possible, say, on a private permission blockchain, because you have this kind of deterministic finality. On a public blockchain, it's a little bit more complicated. I mean, it really depends on which kind of ledger you're using here. So, but mostly you have probabilistic finality. So the question is, okay, how many confirmations I really need, and how to make sure that everything is happening in a kind of reasonable time. So the law is not really clear here. And so there's something which is explored, but it's a little more tricky here. But on a private permission, it's a little bit simpler. Then it also requires, say, a decentralized system. So it's not really clear what kind of degree of decentralization is meant here. So on a permissioned less side or on a public side, you definitely, for most kind of blockchains, you have that, because you have a huge number of nodes. So they're normally highly decentralized. If you go for, say, a permissioned version of the network, I mean, it's somehow restricted by your consortium you're building, how many nodes are involved. So the level of decentralization is, I would say, it's normally lower. Then you have the data privacy issue, because some data, say, a register have to handle could be, say, could be protected according to GDPR, because I mean there's a possibility that you have, like, for a segregated kind of account, you can have like personal data, because there should be like the holder's identity data somehow managed. And so you have this kind of data privacy thing. And you can definitely solve it with, say, a public blockchain, but it's nothing which is in their tool set. I mean, it's more in the tool set of, say, of permission blockchains, which I more would say enterprise ready. You have like Corda or Hyperledger. You have these kind of private channels where you can only, say, exchange data between, say, relevant parties, and the other only sees the hashes. So it's much simpler. Another problem is like governance. Say, on a public permissionless blockchain, you may have the problem with, say, who's running nodes, I mean, essentially everybody, but much more pressing issue is, okay, how to actually update such a system. And, in a past, you have all these, say, nasty hard forks. And if, as a register for securities, you're responsible for your data, or for correctness of your data, this is getting a little bit hard if you suddenly have a hard fork. I mean, it's hardly to manage that. It's much easier to be on a permissioned network, because, I mean, the whole governance model, who's actually joining network, how updates are performed is really, say, up to the consortium here. So it can be really kind of designed. Another issue, scalability. I mean, as I mentioned, in the future, you have more and more cryptosecurities on such a network, and you have like a plethora of corporate actions. So there can be a huge traffic. And with public networks, at least at the moment, it's a little bit kind of hard, because they're trying to solve the scalability issues, but for most, it's not really solved. With permission, it's easier. You can horizontally scale the network. So let's go to the register. So there's also like a lot of kind of problems to be solved here. I mean, first thing is about data. Here you can see, say a high-level architecture. You have the register. I mean, you have some kind of classical IT architecture, maybe running in a cloud, and you have something which is in the distributed ledger. So you have like on and off-chain data you have to manage, because you will have off-chain data, because some data is privacy protected, and you have to handle it in another way, say in another kind of maybe network or in a classical database. But it gives you a lot of kind of headaches, because I mean, you have a functional, non-functional requirement for both kind of data, and you now have to handle it over different kind of systems. Another kind of problem you have to rethink here is, say, compared to more to crypto assets, is that with the private key, you don't control, or you don't prove ownership of the asset anymore, because The problem is the register. The register is responsible, say, for legally compliant ownership. So this is kind of thing where you have to rethink, and it needs somehow to be implemented. I mean, there's a lot of different approaches here. I mean, one thing is like when you have a crypto security smart contract, you can build like a embedded compliance layer around it, which somehow communicates with the registrar over oracles or any other kind of connections. And you also have to think about like if you want to use cryptography, like private public keys, how to make a nice progress. I mean, there's possibilities with say multi-party computation. There's say solutions with multi-signature schemes, but you have to really think about that. And this means something like the registrar is somehow involved when you make a transaction. So once you make a transaction, say a transfer from one owner to the other, the registrar will apply some kind of rules and only sign if the rules are compliant, and then the transfer is initiated. But it's something which will be, I think, will be developed, and there's a different kind of solutions to it. But it's a kind of challenge you have to solve. The other challenge I mentioned earlier is because you want to really focus also on automatization. Otherwise, it wouldn't make much sense. Is if you have a bond, you want to have payments, or if you have like any other instrument, you want to have maybe have payments. So there's different solutions to that. I mean, the simplest you can think of is like a trigger solution where you say your smart contract is somehow connected to traditional payment system, like a SEPA payment system, and you can make transfers between different parties, like between issuer and investor. But this is not really a good solution. It's more, I would say, more kind of workaround. The other one is, okay, you build a kind of a digital euro. I mean, you need maybe an e-money license for that, and you have a payment provider or a payment providers, in plural, it can be banks, and they somehow providing over like, say, redemption issuance functions, a digital euro within the network, and they can be used by, for instance, dividend payments or coupon payments. And but I think the best solution maybe in the future is if you have something like a CBDC or any kind of or commercial bank money, which we can integrate somehow. So we have to connect maybe to DLT or to distributed ledger networks here, so that, say, the security smart contract can communicate with say with a fiat network and make all these kind of payments. So this is something which is possible, but it has to be solved in the future. So to summarize here, so the first challenge we have to solve is, okay, we have to look for the distributed ledger technology. I mean, we have to look into the law. I mean, there's some kind of non-functional requirements, and we have to see how we can solve it maybe now, because I mean, we shouldn't wait too long for that. The other way is we have to find a way to build a registry, and there's a lot of challenges involved, like how to make legally compliant transaction, how to keep everything, say, legally up to date, how to manage on and off chain data in a way that you ensure privacy, authenticity, and integrity. And we somehow also have to realize the problem of payments, and later also like corporate actions like voting and so on. But I think payment is the most pressing issue, because there's a lot of people also working on cash on ledger, on CBDC and so on, and things have to be somehow used here. So that's it. That was my talk, and I still have 1 second left.
Amazing timing. Thank you very much for this talk, Dr. Markus Hennig. There would be one question, if the regie could shortly tell me if there's time for that. Okay, great. You discussed several approaches of on-chain payments of digital securities in the last few slides. Is it crucial for all of them to be on-chain? Does the audience want to know?
It's not crucial, especially if you have a kind of trigger solution. I mean, the thing is, like, say, the smart contract for the security is probably, say, on a distributed ledger, but you, say, somehow can connect it to outer systems. Like you can have like a traditional payment system, you're just trying to connect them. I wouldn't say it's the best kind of solution, because I mean, you're really changing systems. It would be nice to have everything in one system, but I know it wouldn't be, say, possible in a near future. But I think the easiest way is, this was the first solution I suggested, is a kind of, a trigger solution where you connect to a kind of classical payment, say a SEPA system.
Great. Okay. Thanks again for the great presentation.